Hi friends, welcome to lesson 20. So this week is the Halloween week. It means that this week is the last week of October, right? So we have one more month to holiday. Yay! Hang in there. I know you guys want to have a break, but it's almost one more month to go, right? Okay, so please take care of yourself before we can meet each other again, alright? So let's continue with our lesson. So we check our homework for our previous lesson first. Alright. For example 1, right? So your A is 1.95, your B is negative 0.8. We already discussed in our previous lesson already. And for A, there's a range of answer. The answer will be in between 1.9 to 2.0, somewhere around there, okay? And then I accept for that. And for B, I accept somewhere around negative 0.7 to negative 0.9, somewhere like that, okay? It's around there, somewhere there. This is a range, this is not minus, this is 2. Okay, and then for question, this is question 1. We consider this as a question 1, okay? I will pick Adriel's answer here to check, alright? Okay, the table is there, and then gradient is there, and your C, okay, the C, I will check from your graph. Okay, let's look at his graph. Is it negative 0.3? Okay, this is a negative 0.35, okay? So maybe you can change this to negative 0.5, Adriel. Okay, this is negative 0.35, okay? Add a 5 at the back. Okay, after that is reducing to the y-axis and x-axis here. Okay, and then comparing, right? So this is the answer. So the range of answer for B is somewhere around negative 0.3 to negative 0.44, depending on your graph here. Okay, I will check according to this graph. Okay, I hope you check your PDF file already, the one that you sent in to me. I already marked, and please check, double check. And the gradient is somewhere around 2, right? Somewhere around 2. And don't forget to label your graph. This graph must be labeled. This is y over x, and then this is x. Okay, you must label your graph. Right, so let's go to example 2. Today we're gonna include log. Hey, log. Right, so it is known that x and y are related by the equation, okay, where a and b are constant. So this time, okay, you don't see y and x, right? Okay, but then of course there are variables there which we can treat it like x and y. So here they mentioned that a and b are constants. A and b are constants means that the variable will be n and t. Okay, so it's already shown here. Okay, this is your n and t here. Okay, so what they want us to plot is, you check on the one that they say plot this one against this one. So when they say plot this one, means that this one is y. When they say plot log n, this log n will be y. They will definitely say plot y against x1, okay? They won't say plot x against y. So it is confirmed that this is your big Y, this is your big X, okay? Big Y, big X, okay? So, and draw a straight line. So your first step is to draw a table, okay? Construct a table immediately. So when you construct a table, you need to have a new value, okay? You need to have new value. So new value here will be your big X and big Y. You're gonna change that. Okay, I'm gonna fill in here. So this is your big X, this is your big Y. And your big X now is log t. And your big Y here is your log n. Okay, I'm gonna fill in this one. After that, okay, see what they want. Okay, log t, log n. So you don't fill in t and n, okay? You don't fill in t and n. You fill in log t and log n, so you're gonna press calculator just like your previous question, okay? You're gonna press calculator, log t, log n. Okay, I press log t first. Okay, let's press together. Let's double check. Maybe I got mistake. I scared I got mistake. So please help me to check, right? So log 3 is 0.48. Log 5, 0.70. Log 10 is 1. Log 15 is 1.18. And then this one is 1.30. Log n now is log 900. Okay, this log t is from this t. Now log n is this, right? So log 900, I fill in here. So it's 2.95. Then log 2000, I write it there, 3.30. And then log 5000, log 11,000, and log 16,000. Okay, 2 decimal place is enough, right? Okay, so you're gonna plot graph. Okay, now the thing here is they didn't mention what scale you need to draw, right? If they didn't mention what scale you need to draw, so you can agak your graph, at least not small. Okay, don't draw a graph that is smaller than your palm. Okay, I think I mentioned this before in the class. Okay, so for this example, of course, I will give you the scale by myself, by my own. I give you the scale, then you can draw it. Okay, so I will be using scale of for x-axis. I'm gonna write here x-axis. I will use 4 cm to 0.5 unit. And for y-axis, I will use 2 cm to 1 unit. Okay, so 4 cm here is my 0 here, 4 cm, it means here until here, 0.5. Okay, my this one is 1 cm. So until here is 4 cm. Okay, 0.5. So here is 1, here is 1.5. Okay, always look at the highest value here. The highest value for your x-axis is until 1.3. Okay, so I stop until 1.5 here. Right, and my y-axis, I put 2 cm to 1 unit. So 2 cm to 1 unit means here like that. 1, 2, 3, 4, 5. Like that. Okay. Why until 5? Because you see my highest value is 4.20. Okay, so I put until 5. Okay, and then I use ruler to draw my x and y axis. Okay, and then don't forget to label. This is your log n. This is your log t. Okay, y against x. Okay, and then I start to plot. So 0.48. Okay, so 0.48, 0.1 is like this. 0.1 is every small 4 boxes. Okay, so every 4 small boxes is 0.1. So 0.48 is somewhere near to 0.5. Okay, so 0.48 to 2.95. 2.95 is somewhere here. Okay. Right, 2.9 is here, 2.95 is here lah. And then 0.7, so 0.6, 0.7 to 3.30 is here. So it's here. Okay, you plot properly, and then if you draw the line, if it's not straight line, so there's something wrong with your graph already. Okay, 1 and 3.7 is here. 1.1, 1.2, 1.18 is somewhere near to 1.2. Then 4.04. Then the last one, 1.3 to 4.2. Okay. Okay, so after that, I will draw a graph, a straight line graph. Okay, so this is my graph, a straight line graph already, and passing through the sea. You must always draw passing through the sea, because you need the y-intercept to answer your question. Okay, so you can follow my my scale here. Then you can draw it according to my answer here lah. Okay, so remember this. Okay, I recap again. First, you must construct a new table, and then second, you draw a graph. Okay, I've done the step 1 and 2, and then find gradient and see. So I will find gradient from the table here, because whatever that you draw here is according to the table. So instead of picking 2 points from the line, you pick from the table. It's easier. Okay, so I'll find my gradient. So my gradient is, I choose 3.7 because I like the number 1, not much decimal place. Okay, another one more, maybe this one 1.3 and 4.20. Okay, so I use 4.2 y minus y over x minus x. And then you press calculator. Okay, I get somewhere 1.67. Okay, if your answer is somewhere around 1.5 or 1 point something until 2, it's okay. Somewhere there. After I find my M, I find my C. So my C here, according to my graph, is 2.2. Okay, so 2.2. Okay, after that I form a equation y equals to mx plus c. So my y equals to 1.67 big X plus 2.2, which is log n equals to 1.67 log t plus 2.2. Okay, I stop until here. So instead of doing this and make n a subject, I choose to, okay, according to this, the one that I stick to, reduce given nonlinear. Okay, the one that is given nonlinear is here. N equals to at power b, right? Okay, so I'm going to do that. N equals to at power b. I'm going to reduce this. Okay, this is my step over here. I'm reducing this one, so I log both sides. I hope you remember how to do this. Remember this or not? Okay, so log n equal, this one I break it into plus, and then I bring down the b. So b l g t. Okay, and then I exchange the I exchange the place like this for you to easy to see. This is your big Y, this is your big X. Okay, this is your M and C. Actually, you can compare already. Your B is equals to 1.67. You see that? And then your log A is this 2.2. You're comparing now. The last step already compare. So you compare this one with this one with this. So I'm going to write down there. Your B is equals to 1.67. Done. And then your log A is equals to 2.2. Okay, so to find this A, what I do is I move the LG, become 10 to the power of 2.2. So 10 to the power of 2.2 is 158 in 3 significant figure. Okay, so this is my answer, and this is my answer for A and for B. Okay, and if your answer is different with mine, let's say, okay, it's all depend on what value you are using, because if you're using the gradient that using different points, you will get a different gradient, but the different gradient is not much difference from 1.67. It's somewhere around 1 to 2 like that. Okay, and this range of A, it will be somewhere around 150 to 200. Okay, this is a range of answer, as I said, depend on your graph and depend on the gradient that you found. But if off too much, then it's considered wrong lah. Okay, so okay, I've answered part 2. This is part 2 answer, part 2. This is my part 1 drawing graph, and then part 3. Okay, now we have part 3. In this lesson, we have part 3. Estimate value of n when t equals to 8. Okay, now we want to find the value of n when t equals to 8. Okay, so we already have our equation here. Okay, I'm going to use the original one. N equals to ATB, because we have A and B already here. Okay, n equals to ATB. Okay, so you're finding n. Your A is 100, and I will be using the original one. The original one is before rounded off one, the one that without rounded off one is 158.489. Right? Yep. So I put 158.489 because it's more accurate. And then your t is 8, and then to the power of 1.67. Okay, so I press calculator. This one times 8 to the power of 1.67. So answer is 5,106.9 something. And they say round off, give your answer correct to nearest 100. Okay, nearest 100. So if nearest 100 is 5,100. Okay, so this is my answer. So the answer for this is somewhere around 2,000 to 5,000. Is big number because of the log, right? So the range of answer that we accept is somewhere around 2,000 to 5,000. Okay, it depends on your B and A if it's correct, and also your graph. Okay, so that's for question example 2. So your task today is question 2. I put this one as question 2 lah. So same kind of questions, and this time I give log question. This one you definitely need to plot log y, see, against x. Only the log for the y, not the x. X is normal x. Okay, so this will be your big Y, and this is your big X. Big Y, big X. So the scale, okay, I think I'm gonna give you the scale, because if I don't give you a scale, macam-macam lah your graph you give me later. Okay, so first step, remember to construct a table. Okay, construct a table you construct by yourself. Okay, the one that I want to tell you is your scale. Okay, so you use this scale. So x-axis, you use 2 cm to 1 unit. 2 cm to 1 unit is somewhere like that. 2 cm, this is 2 cm. And 1 unit, so means that this one is 1. And then 2 and so on. Somewhere like that. On your y-axis, 2 cm to 0.5 unit. Okay, so like this, around, this is 2 cm. So it's 0.5, 0.5. Okay, so just follow the scale that I give you. Alright, so this is your question, and that's all for today. Your lesson 20 is example 2 with question 2. Okay, that's all from me today. Right, thank you guys. See you guys again. Bye.